If you are an chemistry biology aspirant and if you are interested in writing teachers competitive exams like HSTR or KV or TET exams, then you must know all about a periodic table, at least basic points about a periodic table, and I believe that many of you know it as well. Hello friends, welcome to my YouTube channel Unfog with Dr. Atahar Parveen, and come on, let's explore and have a brief idea about a periodic table. Dmitry Mendeleev, he proposed a periodic table in mid 1800s, and he proposed this table for only 70 elements based on increasing mass and their similar properties. Then later in 1913, Henry Moseley, he determined the atomic number of elements and arranged the table in order of increasing atomic number. Actually, you can see how elements are placed in a periodic table. There you will have an atomic number, you will have an atomic mass along with the symbol of that element, and also the name of that element is also given below that symbol. For example, we have a symbol H for hydrogen. The atomic number of hydrogen is 1. That means a number of protons in an hydrogen atom is just 1, and then the atomic mass is also mentioned in the top right corner. What is atomic mass? It is nothing but the mass number of an atom. That means a total sum of number of protons and neutrons present in the nucleus of that atom. Okay. We have 118 elements in the periodic table. I always wondered in my childhood, why do people call a periodic table as periodic table? Means why is that word periodic there in that phrase? They call it as a periodic table, right? They don't call it as an elemental table or something they could have called, right? But they are calling it as a periodic table. The reason which now I understand very nicely is that there is a periodicity in the periodic table. That means the periodic table follows a periodic law. The regular variations or patterns of properties are there in that periodic table, and these regular variations or patterns of properties, they are with increasing atomic weight. Not only physical but chemical properties also, they vary in a periodic way or in a repeating fashion in a periodic table. Okay, that's the reason why we call it as a periodic table. And how the elements are placed in a periodic table? They are placed in a proper fashion as per the periodicity of their physical and chemical properties. Now this is a periodic table, and here the elements belonging to same family, they are put in a vertical column known as groups. There are 18 groups in modern periodic table. Now how the elements are divided in these groups? Generally, for neutral atoms, valence electrons or number of electrons in outermost shell, this number of electrons in outermost shell is equal to group number of that element. Okay, that is how they have put these elements into groups. And also the horizontal rows of elements in a periodic table, they are called as periods. So there are groups and periods in a periodic table. As we move from left to right in a period, the atomic number of elements increases, which means that number of protons and electrons in an atom increase. As we move from left to right of a period, the atomic number of elements increases. Okay. Now based on atomic orbitals, the periodic table is divided into S, P, D and F blocks. Total there are 18 groups, right? Now this S, P, D and F block, they belong to some groups. Like for example, S block, it belongs to group 1 and 2. Okay, 1A and 2A. Next is a P block, which is in the right side of this periodic table. This belongs to 6 groups, 3A till 8A. Next comes the D block, which is in the middle. The D block. The D block, it belongs to 10 groups. And below there is a F block. This F block also belongs to group 3. Okay. So they have written it in such a manner that it looks like it is separately there. But actually the elements from F block also belong to group 3. Okay. So remember that F elements, the F block elements, they always belong to group 3. Okay. Now using this information of SP, D and F blocks in the periodic table, we can also find the electronic configuration of a particular element, right? So I am sure many of you or all of you will be knowing about this. So we write an electronic configuration to fill the shells around the nucleus in an atom, right? So we go on filling the shells right from the nearest shell to the nucleus till the outermost shell, correct? So we have a Aufbau principle which guides us how to write an electronic configuration. According to Aufbau, electrons will occupy the orbitals having lower energies before occupying higher energy orbitals. Here is a diagram which helps us to write the electronic configuration. So according to this principle, electrons are filled in the following order. First you have 1s, then 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, 5s, 4d and so on. So this is how you write an electronic configuration. Anyway, that needs one separate class. So we will not go into much detail about the electronic configuration right now, because we want to have one quick review about only periodic table. Okay. So let us move towards our periodic table. Now, as I was talking about the groups in the periodic table, the groups are 18 groups, right? Now they are divided into alkali metals, alkaline earth metals and transition metals. Now these alkali metals, alkaline earth metals and transition metals, they belong to metals. They are all group of metals. Next are lanthanides and actinides. Then halogens are there and then noble gases are there. So we will have one quick detail point regarding each of these groups. Okay. Now before that, let us see what are the SPDF elements. Okay. So this one is S block elements. Right from hydrogen till helium and then moving towards till atomic number 88, that is radium. All these elements, they are S block elements. Okay. Basically the left portion of the periodic table and just helium from the right portion. Now these are the elements in S block. Group 1 and group 2 is there except helium. Okay. Now hydrogen, lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, cesium, barium, francium and radium. These are all S block elements. Okay. Now these are P block elements from boron till atomic number 118 OG. Okay. So the right portion, basically the right block except helium, that is your P block elements. Okay. Now these are D block elements. D block elements means from scandium, titanium till atomic number 112. Copernicium, I think it is Cn. Okay. So these all elements, they belong to D block. Along with that you have lutetium and lawrencium also. Atomic number 71 and atomic number 103. These also are the elements which belong to D block. Okay. Now come the F block elements. In F block we have this lanthanum, atomic number 57 till atomic number 102. Actually from atomic number 57 to 70 means lanthanum to yttrium, that is one part of F block, and then atomic number 89 actinum till nobelium, atomic number 102. Okay. So much are your F block elements. Now these were the partition of the periodic table in terms of S, P, D and F blocks. Okay. Now we will go into different type of classification. Like a group of metals. I told you, right? In metals we have alkali metals, alkaline earth metals and transition metals, right? So these are all elements which belong to the group of metals. Metals means basically they are those materials which have high electrical conductivity, and they have nice shining, that means they have luster. And most importantly, metals are the materials which are having ductility and malleability, means they can be easily made into thin sheets and thin wires. Okay, now all these elements which are in the upper left portion and F block elements are also there except hydrogen. These all are showing metallic properties. Now in this we have alkali metals which are lithium, sodium, potassium, rubidium, cesium and francium. Now these are belonging to group 1, and the speciality of these elements is that first of all, they are metals, alkali metals, right? Now they are very reactive. They are ready to react. Okay. Next, they are soft solids and they always have tendency to lose one electron. Okay. They have tendency to lose electron. That's the reason why they are becoming so much reactive. So whenever you have lithium, sodium, potassium, rubidium, cesium and francium, you should think that they are highly reactive metals. Okay. After alkali metals, we have in this group of metals, alkaline metals. These are belonging to group 2, right? Now these metals speciality is that they are found in abundance in earth. Okay. They are abundant metals in earth. What are they? Beryllium, magnesium, calcium, strontium, barium and radium. Okay. Now metals, they are not as reactive as the alkali metals, but their abundancy is their speciality. Okay. Now third part of metals are the transition metals. These are the elements which belong to group 3 till group 12 actually. Okay. Now what is the importance of these metals means? They are very much important for us, basically for living organisms, that is as minerals. We take supplements, right? Iron, zinc, magnesium. So these are all very much important for our health and to take care of our body. So this is the main speciality of transition metals. Now we have elements known as post-transition metals also. They are also known as poor metals. Now these metals, they are known as poor metals or post-transition metals because they are located between transition metals and non-metals. Now these are non-metals, right? These are post-transition metals. These are transition metals. Now these post-transition metals are between this transition metals and non-metals. Okay. Now talking about non-metals, these are the elements which are placed in the upper right corner of the periodic table. These materials do not shine or they are non-lustrous, and as they are non-metals, they are poor conductors of electricity. And what is their state? Some of them are gases at room temperature like oxygen and chlorine, and some others are brittle solids. Brittle solids means to look at they are hard substances, but they are very easily breakable. Okay, they are easily breakable solids, you can say. So they are brittle solids. Now let's talk about metalloids. These are the elements on the stair-step line that divides metals and non-metals. They exhibit properties that are intermediate between those of metals and non-metals. Basically, they are mixture of metals and non-metals, you can say. Okay, the properties. They exhibit the properties which are mixture of metals and non-metals. Now, what are important metalloids are silicon and germanium. Okay, silicon, though its name only has a Silicon Valley is only there with its name, right? So all integrated chips and all those are made using silicon. Basically, these are semiconductors actually. Okay, so the important metalloids are silicon and germanium. Now come the elements belonging to noble gas. This group 18 elements are there, no? They are your noble gas elements, and they are usually called as inert gases because they are non-reactive. Okay, and as we are telling that they all are gases only, right? We are calling them as noble gases. So their state is in gaseous thing only, and they are gaseous in state at room temperature. Okay. Now what are the examples for noble gas? Here so you can see only 6 are there: helium, argon, neon, krypton, xenon and radon. These are our noble gases. Okay. Now let's talk about reactive nonmetals. Group 14, 15, 16 and 17 consists of reactive nonmetals. Elements like carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine and astatine. These are reactive nonmetals, whereas only these group 17 elements, fluorine, chlorine, bromine, iodine and astatine, they are given one separate name as a family. It is known as halogens. Halogens, they react very fast, that means readily they react with alkali metals, and among this group, fluorine is the highly reactive nonmetal. So a question can be asked like this: which is the most reactive nonmetal? Your answer should be fluorine. Okay, this is an important point, that fluorine is a most reactive nonmetal. Actinides are these elements starting from atomic number 89 till atomic number 103. Now these elements are actually radioactive elements. Okay, what are the examples? Uranium is there, plutonium is there, then berkelium is there. All these are actinides group. And next is the lanthanide. Now these lanthanides, they are also known as rare earth metals. Okay, rare earth metals, very important. Now these also are present in F block. These are soft silvery metals. So right from atomic number 57 till 71 we have these lanthanides or rare earth metals. But not only this, we have two more elements belonging to this group, that is atomic number 21 and atomic number 39. Scandium and yttrium. These two elements are also sometimes included in lanthanides only. Now this was all about our periodic table. Now one interesting fact I want to tell you. We were talking about the group numbers, right? Now how you decide which element is belonging to which group is very interesting. You know what are valence electrons, right? Valence electrons are the electrons which are present in the outermost shell of the atom. They are the one which are able to interact with other atoms and form the chemical bonds. Now these valence electrons will give you the valency of the atom, right? Now how many number of valence electrons are present in that atom will also give you the group number of that particular element. Okay, so the valence number and the group number is same. Okay, for representative elements S and P blocks, the number of valence electrons, it will be equal to last digit of the group number. Like all the elements which are belonging to group 1 and 2 will have valence electron 1 and 2 respectively. But if the elements are belonging to group 13 or group 14 or group 15 or group 16 or group 17, then the valence number of those elements will be equal to the unit place number. Like the unit place, we have units place and tens place, right? In units place you have 3 in 13, you have 4 in 14, you have 5 in 15, you have 6 in 16 and you have 7 in 17, right? So this number will be equal to the number of valence electrons in that atom. Like for example, if the element is belonging to group 13, then the valence will be for that atom, it will be number 3. Okay. If the element is belonging to group 14, then valence electrons will be 4. If the element is belonging to group 15, then valence electrons will be 5. If element is belonging to group 16, it will be 6. And if it is belonging to group 17, it will be 7. For group 18, no. The elements which are belonging to group 18, these are exceptional. They have no valence electrons because they are generally not available for making chemical bonds. We are talking about the inert gases. They are group 18, right? They are not at all ready to react only. That's why they don't have valence electrons, and group 18 elements are the one which will not be having the same group number, that means the unit digit place number and the valence electron number. Okay. So this point you can take it as a trick also. Number of valence electrons will be equal to the group number in case if it is a single digit. If it is two digit number, means the group number is 2 digit, then you take the units place number. That will be equal to the number of valence electrons for that element. Okay. So this was all about periodic table. I thought that before starting to take any chemistry class, it's better that I give one nice glance on periodic table. Then it will be easy to relate, right? And also for any competitive examination, if you are a chemistry aspirant, then periodic table is like ABCD for you all. So it's better you make some mnemonics or some shortcuts and you learn the periodic table. For example, you can learn first 20 elements like this. What I have done is I have made some sentences I have joined, and for every word, the first letter, the first alphabet is giving you the first letter for the element. Like I have made this thing, see here. Happy Harish lives beside big cottage near our friend Naresh Nair Murli, and Savitri Prerna stay close to Atahar Khatija Catherine. So this is one sentence. If you can learn this sentence, it will be playing like a mnemonic for you to remember the first 20 elements of the periodic table. Happy means the first letter is H, right? H for hydrogen. Harish, again H for helium. Lives, L for lithium. Beside, B, beryllium. Big, B, boron. Cottage, C, carbon. Near, N, nitrogen. Our, O, oxygen. Friend, F, fluorine. Naresh means N for neon. Nair, N for sodium. Murli, M for magnesium. And A for aluminium. Savitri, S for silicon. Prerna, P for phosphorus. Stay, S for sulfur. Close to, C for chlorine or Cl for chlorine. Atahar, A for argon. Khatija, K for potassium. Catherine, C for calcium. So you can make your own sentences like this in your own language. It can be Hindi, it can be Kannada or any other language, and try to learn the atomic numbers of those elements. Means try to learn the name of those elements along with the symbols in order. Either you do it with the atomic number thing or you do it with the SPDF thing. It is up to you how you want to learn. Okay. Or you can do it with like group of halogens you can take, group of inert gases you can take, group of alkali metals you can take, group of alkaline metals you can take, group of transition metals. They will be little more, but then again you will have to make some mnemonics and shortcuts to learn those. Okay. So better you learn them. You cannot do it once at a time. I am sure many of you will be knowing many of the elements in the periodic table. But in case you don't know, this is the right time for you to learn the periodic table. Okay. You need to start learning periodic table right now. When you are watching this class, as soon as the class finishes, you have to start learning the periodic table. This is the assignment for you all. Okay. So if you are a HSTR aspirant, then make it sure that you are learning periodic table. At least start learning it right from today. Okay then, please do like, share and subscribe to my channel, and also we have a Telegram channel. I will give the link in the description. Please do join the Telegram channel, and there are also many free videos available in this YouTube channel based on HSTR, chemistry and biology. All the links will be given in the description. Please go and watch those classes also. And once you join the Telegram channel, you can be in contact with me. You can personally talk to me because there is an option of entering into a group through the Telegram channel. Okay. If you are having any query or anything related to the paid classes or anything related to chemistry or biology, please feel free to write down in the comment section. Okay then, like, share and subscribe. Thank you. All the best. Bye.